Okay, I think that is good. Um, all right, sweet. Welcome to the legendary pipeline tutorial. I'm going to post a link both in the chat and on the Slack channel. Okay, great. So I just posted a link to a thing that I wrote up yesterday. In typical me fashion, I was like, okay, I should like write a few notes to myself, make sure I don't skip anything. And then it turned out to end up in this like 15-page document. But everything we're going to do today is just pretty much from this, but I'll obviously go through it with people, make sure that everyone can do all the steps. So yeah, let me just share my screen. We can start. Okay, cool. So let me log in and just demonstrate how you would normally download data. So normally you would go to the Supernova Exchange, and if you wanted to download all the data of an object, you just go up to this top tab thing over here that says batch download data. This lets you download all the data you want. If you want to download all of the images, you can do that. If you want to just do a subset of them, you can do that as well. That will make Snex put together a tarball, and then it will email you links to the tarball so you can download them. But for this tutorial, I've already put together a few tarballs, so let me So these should be all of the things that people have already downloaded: 3 tarballs of data and a catalog file. And
Jamie, could you make the font just like 1 or 2 bigger?
yes, good suggestion. Is that better?
I would say that's minimal for me. Other people speak up if you want bigger.
Bigger, please.
Sounds good. Sweet.
Thank you.
All right, good stuff. Thank you for asking. Okay, so these are the 3 tarballs that I sent around, and also the catalog file. And so, like the tutorial document says, in order to make this data accessible to your Dockerized pipeline, you have to put it in the right directory. I don't know how familiar people are Docker. We don't really need to go into it right now, but it basically creates like an entirely separate part of your computer that's running totally its own subset of software. So in order to make that part of your computer access the rest of your computer, or access a subset of the rest of your computer, you need to pass things in correctly. And so during the tutorial, or sorry, during the pipeline installation, one step was this exporting a directory as wherever you wanted to put your data. So for me, I have all my data in a home directory that I just called pipeline data. And then I have a subdirectory in there with all of my tar files. So this is where you have to put stuff in order to get it passed into the Docker container.
I noticed, Jamie, the catalog file goes in there as well.
That's right. Yeah, the catalog file as well, because we'll also need to pass that into the pipeline.
Thanks.
Yep. Cool. So we'll copy paste some stuff. So this is also one step of the installation. It's starting up the pipeline server. In this case, I'm putting an ampersand at the end so it runs in the background. Whoops. A good instruction. So you have to run this in the, whoops, that's what I want to do. So you have to run this command in the place where you cloned the Git repo. So this Docker compose command starts the pipeline server, and then I'm going to put in ampersand at the end, which will run it in the background. So okay, it says starting the database, does a bunch of stuff. Now it's ready for connections, so that's good.
Hey Jamie, I have a quick question.
Yes.
So in the setup for the Docker, it said that we're supposed to create those pathways, to export those pathways for your data and the SNDB directory. When I do an echo for the SNDB directory, LCO SNDB directory, I get nothing. But it said it was supposed to create those if you don't already explicitly export those, correct?
Yes. So I think what might have happened is that you exported it, but then it got lost somehow.
I didn't do those steps at all. I just said Docker will automatically create them. So I have one for LCO SN directory.
Okay.
But I don't have one for the DB path.
Okay. I don't know if that matters as much. Definitely the SN directory is much more important.
I think it matters for the starting up of the database.
Could you, yeah, Sam, could you do this step, the Docker compose thing?
Yeah, I have all that running.
Okay.
Okay, I'm not gonna worry about it.
It's the same for me. I have it, I left it undefined and it's running. I mean, the Docker compose is running, but there's nothing when I echo LCOS and DB path.
Okay, so those environmental variables should be set inside the container, but they might not be set outside.
No, that's when echoing them inside the container.
Yeah, me
LCOS
too.
and DB path is empty. But the other one is not. The data one is okay.
Curtis, do you want to chime in here? I think you were part of defining these variables.
Yeah, I was just looking at the code. Give me 1 second.
So part of this is that like all of your data is going to live in this like LCO SN directory, and then your database is going to live in this other directory. And by defining a variable, we can all just the code can all refer to the variable, and then everyone can have it wherever they want it on their machine. And that was a big motivation for making this kind of globally usable.
Mm-hmm. And when we are doing like a tutorial directory, do we have to explicitly export our data directory and then concatenate tutorial data or something like I'm just going off the same structure that you have, Jamie?
There's the step where you have to put the catalog in a very specific place. But besides that, as long as your tar files are accessible from inside the Docker container, then it doesn't really matter where they live.
Okay.
The database will store the path to the files, the individual data files.
Okay, so I'm gonna do
So-
yeah, sorry, go ahead, Cruz.
No, so I was just looking at things again. Where I'm looking at the doc, and you said it's the LCO SNDB dir or something like that. Is that what it is, or
Mhm.
which environment variable? The DB dir. Step 9.
LCO SNDB path. So it says it will, if
Okay.
you don't set these environment variables, they default to being data in MySQL in the repo directory.
That's right. So that particular path only matters outside the Docker container. I don't think that's a problem. The ones that actually matter for using the database are in the Docker compose file. They're like the host, the LCO SNDB host, the LCO SNDB name, and LCO SNDB user. So if outside the container you do an ls inside the directory you ran Docker compose, there should be either a data or a MySQL directory there.
Yeah, I see that.
So that's what that particular environment variable controls, is where that folder ends up on your local machine outside of the Docker container. So sorry, that was a bit of confusion.
Okay.
Okay, so let's we can do the next step. So we did the Docker compose, which sets up the database, and then the next step is to do this Docker exec, which puts us actually into the container. So that's good. Now we're just in a mostly empty thing. So I'll cd to where my data live. So this is the exact same, I don't think I asked above, but this is the same directory that's in my accessible on my local computer. So hold on 1 second. So now I've got my tutorial tars file, tutorial tars directory, which is where I put all the stuff. So now we're gonna ingest that into the database. So there's this ingest tar thing, ingest tar script. So we'll just run that individually on all of the 3 different tar files. So you just specify the file with -f, and then that'll ingest them into the DB. This takes a minute for each of them, but that's fine.
I also have a problem. It said when I type the Docker build -t, it said build does not exist. So maybe it's related to data structures. I put errors in the chat window.
Yeah, it's just looking at the.
I was also having an issue before trying to get the X Windows forwarding working. And so I will admit my version of Mac is slightly outdated. So I don't know if that has anything to do with the like SOCAT hack that was there working or not working. But so like when I run the ingestar thing, it says there's no display to forward to. And I assume that's going to be a problem later on. But I was wondering if there's any fix around that.
Yes, it will indeed be a problem. So what do I want to say? So could you install SOCAT at all?
Yeah, I mean, as far as I can tell, it's there and it's running. So like I ran SOCAT in the background in the same terminal window that I ran the docker exec command in. And it didn't give any warnings or anything like that. So I don't know exactly how I would go about debugging that to see if it actually is doing what I think it's doing or want it to do.
Let me, okay, and you, I'm gonna post this in the chat. You found there's a line down below in the use section. That's the SOCAT TCP listen thing. Are you running that line?
Yeah.
Okay.
Yeah.
Then I'm not sure what to say. Curtis, any thoughts? Please save us, Curtis.
Yeah. Sorry. Yeah, actually, I was going to say, do we have the breakout room thing that I could spin out with him for 2 seconds and see if I could get him going?
That is a great question. Let me try to.
Jamie, if you let people select their own breakout rooms, then I think you don't have to set it up. You just have to create a room, and then I think like Curtis and Kyle can put themselves in the room, and we can continue to do that kind of throughout the tutorial as needed.
Okay, then let me, well, this is interesting stuff. Oh, let me go to security. Sorry, I'm not usually the one running rooms. Okay,
Do you see the
allow participants to blank?
No, it's so at the bottom of your screen, like where it says participants reaction share screen, there should also be a breakout room. Actually, if you make me co-host, I can do it, if that would help.
Yeah, that would be super awesome.
So you can make me co-host, I believe, from the participants window. Awesome.
Sweet. Thank you.
So how would I know if the X11 is working? I mean, it also seemed to go fine for me, but I didn't actually test it. So what would be the, well, I guess we'll get there.
Yeah, so you'll get there once this is done. I can just, so if you just type the command X eyes, that'll just open up. That should just open up a little window. And so if you can open up any window, then it'll work.
Okay.
So I just use this to test.
I actually have some problem in pulling the Docker image itself, and it's saying some really weird error message to me.
Can we, Curtis, are you okay being in a breakout room and like handling people's questions?
I think I already sent him to the breakout room. I can keep sending people, but they'll get behind. I don't know. I'm wondering if it's worth moving on, having people watch and listen, because I think that's a lot of the tutorial. And then we can have like a troubleshooting session maybe at another time, or like an office hours that people can just like drop by and we can try and troubleshoot things.
I'm good with that.
It sounds okay to me. Yeah. I just overall question, step 6, it said Linux only. So if I have Mac, can I step entire step of that, number 6?
That's correct, yeah. So
Okay.
step 6 is just for allowing this X Windows forwarding thing. And Craig and Curtis found that solution for Linux, but there's a separate solution for Mac, which is this SOCAT thing.
Oh, so I have to do something else if I have Mac?
So there are the two steps above that say Mac OS only. So there are.
Yeah, I did that. Okay.
Okay, good. Then yeah, you're set.
Okay.
Actually, this is Luis. I was panicking because I managed to install everything the other day, and now it was not working. And in the first step, it says explicitly to open Docker, you know, the app in Mac. I'm not sure if Jongi has this problem, but I just opened the app, the first thing, and then now it works perfectly. I'm able to, you know, to connect and no errors. But yeah,
Oh,
I'm not sure if others have this problem.
Okay.
Yeah, you have to
That's good to know.
start opening the Docker first thing.
Yeah, then
The
I see the right. I message Docker run this command. So I did that on the terminal. Then nothing happened. Give the error
No,
message.
but if you remember in the installation at the very first point, you are supposed to install some kind of, well, I'm sorry if I say this wrong, but some kind of application called Docker. I have no idea what
Right,
this
I
is.
have that.
Yeah, so you have to open it, clicking somewhere where you have that.
Yeah,
tab.
I opened the
Once
Docker.
this is okay, so to me this solved everything, you know, because while this is open, I could, you know, Docker build, Docker compose, Docker everything. Because without this application open, it was giving me errors all the time. So I just wanted to mention this in case others have this problem.
You should be able to tell if it's running, at least on Mac. In the top right, there's this little symbol with like a whale thing, and it says Docker desktop is running.
Yeah.
And if you want to check from the command line, you can type Docker space PS, and that should tell you if it's running or not.
Okay.
Hey, Jamie, do we need to hop onto a pro account?
Yes, I was just about to bring this up.
I've just created a meeting. I can throw it in and we can just switch over there.
Okay, you're a saint. Thank you, Esley.
Yeah.
I did it through UCSB and I thought that made things work, but I haven't actually set up many things. So yeah, thank you.
Yeah. I think it's okay. We just watch today how demonstration, then maybe we can catch up later. Maybe too many people have different problems.
Okay, I've just put a new Zoom link in the pipeline Slack channel. Can everyone access that if we switch over to that link?
Would you be able to also put it in the chat? I'm not a part of that Slack channel.
I can. Actually, let me reply to Jamie's email because the chat doesn't allow you to copy paste out, and I don't know that you can join a Zoom meeting not in a Zoom meeting. So I'm gonna reply to the email chain that we have going.
Sorry, I missed. Why are we switching Zooms? Because of the remaining time.
Yeah, I don't usually create meetings, so I thought this was under the right account and would be unlimited, but unfortunately.
Okay, but
you need.
We'll just continue the recording on that side.
Yeah, we'll figure out how to put them together into a single recording.
Okay.
Okay, so I think going forward, if your current installation isn't working, sit, watch, take notes, and we will get a working version in office hours at another time. So let's go ahead and switch over to the other Zoom now.
Let's start the recording. Share my screen. Okay, sweet. So, all right, we're moving. We're doing great. Okay, so the other commands that I run are just ingesting the other two tar files. So I was doing that slightly in the background. So now all the data are ingested, so that's good. Like the tutorial document says, every time you ingest a new target, you should run this compare catalogs.py command. So this creates Garbage. Give me 1 second. I think I know how to fix this. Okay, that only happened for me because I had done this yesterday and am now redoing it today. So let me fix that. Classic.
I don't know that force works on compare catalogs.
Yeah, bummer. Can other people run this command correctly? This compare catalogs thing?
Yes.
I got some SQL. Well, I got some output. But
Okay.
what does this command do exactly?
So this generates the catalogs for all the targets. So it goes and pulls stuff from APAS and Sloan and Gaia that will be used for selecting PSF stars and also for 0-point calibration.
Okay, so this is not specific to things with U-band. This is for everything.
Correct. This is for everything.
Okay.
Okay, let me fix this.
Also, this might be while you were working on this, maybe might be a stupid question, but if I exit the Docker and come back in, this is all still saved there, or does this need to be redone?
Yes, it is all saved there.
Okay.
Okay. Okay, give me 2 minutes to fix this. Okay, fantastic, good. Okay, yeah, so when you're on compare catalogs, the output should look something like this. It finds things that don't have catalogs and then goes and generates those for you. I'm gonna have to do this one more time because I missed one thing. Okay, great. So we have ingested the catalogs. Like I said in the tutorial notes, we also have to move one catalog to make sure it's in the right place. So let's do that. Okay, this is removing a special standard field catalog. Those don't get generated automatically, so we have to do some manual stuff to make that work. The next step in the tutorial is to log into the database, because we have to do some extra stuff to make sure that the standard stars will work. So this is the command to log into the database. MySQL, the host this is all very clever and secure. As you can see, the host is called SupernovaDB. If you're on an older installation like SD, the host might be host.docker.internal. The database is called Supernova, the user is called Supernova, and the password is called Supernova.
Jamie, can you just say which are any of these steps specific to the fact that there's UBAN, this landlord catalog? Is that part of it, or is it also generic?
That's right. The landlord catalog and the stuff that we're doing with standards is specific to UBand.
Okay, so these database commands as well?
Yes.
Okay, thanks.
Yeah. Okay, so the database has several tables, but we're only really going to worry about two of them. One of them is targets. So this lists the different targets. So we've got the ones that I chose were 17 CBV, 18 cow, and then this standard one, L101. There's also Photo LCO is probably the other most important table. This is the photometry table. You can see all of our data are ingested into there, and there are a ton of columns with a bunch of different magnitudes and 0 points, telescopes, and all that stuff. If we go back to targets, we have to do two things that I wrote down in the doc to make sure that the standard gets recognized correctly. So in my database, L101 is target ID 10. L101 is the standard, so I should targets set classification ID equals 1. 1 is for standards, where ID equals 10. And then I have to do this other command that is also in the document so that the catalog gets, we know what the catalog is named and how to access it. Okay, sweet. Part 1 of the tutorial done. we'll definitely be done in an hour. Well, okay, great.
How did you get out of the SQL?
Control D.
Okay.
Yeah, I don't know what the actual SQL exit command is. Okay, great. So this was all set up. Now we're going to do the actual reduction stuff. So, like I said in the document, let me just pull this over so I can reference it. So like I say in the document, there are several steps, but there are basically four important ones. So there's generating the PSFs for the files. There's measuring the PSF magnitudes, calibrating the 0 points for each of the images, and then doing the actual magnitude calculation. So those are the 4 main steps that you do, and then you check whether each step worked correctly. So, like I also say right after that, I very strongly recommend doing each object in a separate directory. The pipeline makes a bunch of auxiliary files, and especially if you're doing 2 reductions at the same time in the same directory, then you can have like auxiliary files from one object being used accidentally for another object, and like everything gets messed up. So I strongly recommend doing everything in separate directories. So we're going to do 17 CBV first. So I'll go into my 17 CBV directory. For historical reasons, the main command is called lsc loop. So that's all the commands that we're going to run are somewhat mysteriously called lsc loop. So if we just want to look at our data, the general thing is lsc loop -n for the name of the supernova, and then -e for the epoch. So I got 2 epochs. One of them is on 2017-05-15. And you can see there's a nice full set of photometry on that day. So UVV, GRI images on that day. This outputs a bunch of stuff, the file names, the object, the filter. This says whether the WCS is good or not. 0 means it's good. This says whether it has a PSF or not. It doesn't have a PSF. And all the other stages aren't done yet as well. Okay, great. So open up a DS9 window. And then I'm just going to copy the command that I listed in here. So again, I'm selecting some data by name epoch and now just filter to limit myself. And then I'm running the PSF stage on that. And also running it with the show command, so it will show you the output. It will pop up a window with the PSF and show you the image and what the PSF looks like. So this can take a variable amount of time depending on how crowded the field is and how many stars it's averaging in the PSF and some other factors. Usually it takes somewhere between 15 seconds, like 10 seconds and a minute per image. This is a slightly crowded field, so it'll take a little bit longer.
So I don't know if people are looking at the chat, but I could put the command we're running in both the chat and on Slack because I know that's going to scroll off pretty quickly.
Yeah, thank you. Oh, I guess I didn't post the link.
And
did I post the link?
I put the link back.
Okay.
Yeah, I'm guessing this is also all in that tutorial document.
Correct, yeah. Okay, so that finally opened up. So this is our image. All the possible stars it could have selected from the catalog are listed in gray, so that's what all these circles are. The blue stars that are circled in blue are the ones that were actually picked to generate the PSF. This also lets you, check the image, see if there's anything weird going on with the image. And then the PSF is over here. So this looks like a good PSF. That's nice and symmetric. There's no like weird bumps on it. The signal to noise is very high. So that looks good. Normally this would go do the second one, but I'm gonna kill it and copy the next command that's in the document. So that's in Slack now as well. So okay, we got LSC loop. We're picking the supernova, picking the epoch. We're running the PSF stage. You can pick which catalog you want to use. So by default, it uses the Gaia catalog. We changed that relatively recently. I'm changing to the APAS catalog because there are a lot fewer stars in it, so the process will run a little more quickly. You can also pick how many stars you want to average together to make the PSF. The default is 6, but I'm going to double that to 12. And you can also pick if you look up here, these are the stars that were picked for the previous image, and it lists in the star's profile what the minimum count number and the maximum count number is, data max and data min. I'm going to exclude bright stars, so I'm limiting it to data max of 75,000. And then the last thing here, -F, this is used pretty frequently. This is just force, so it'll redo stuff even if it already has PSF done. So it'll redo that first image.
Jeremy, is your typical workflow 12 PSF stars rather than 6, or are you using that to demonstrate that as an option?
I'm using that mostly to demonstrate that as an option, but I do increase it pretty frequently. Okay, looks like there was a problem. Sweet.
I'm getting the same error you got.
Fascinating.
Yeah, same here.
I think it's the I've always used -- catalog and given the path to the catalog rather than field. I feel like I use field at the ZCAT stage, but I don't know if that's a limitation or just a workflow.
It should have, I think it automatically changed it to catalog, but let's open up that catalog, and there's nothing in there. Cool. So other people are having this as well?
Yeah, I got the same error.
Okay, fascinating.
And Curtis said you will solve it in Zoom.
Clearly.
I'm going to blame APAS on that one because I swear to God I ran this yesterday and everything was fine. That's a real bummer.
I mean, can you try showing it with like the Sloan catalog or something?
I think 17 CVV is not in Sloan.
So we don't have a Sloan catalog.
So let's use another option. Did I do that correctly? Okay, yeah, cool. Slowing things on the fly. Sweet. Okay, yeah, I have no idea why the APAS catalogs are empty. I ran that command yesterday and they got filled out correctly, whatever. So I'm gonna switch. So if for whatever reason you don't want to use the catalog files that you generated, you can use Sextractor instead. So that will that'll run on each file and like in real time pick out sources and then select them. So that's just what all this output is. It's finding sources. I copied that command into the chat as well. Okay, this might take a minute, and by a minute I mean 12 minutes. But cool.
So what we're changing here is the stars it uses to decide on the PSF, or the catalog it uses to locate the stars to decide the PSF.
That's correct.
And the default you said is Gaia.
Correct.
And that took a lot of time. Was that the reason we didn't like it?
That's right, yeah. It probably won't save very much time now. But yeah, the Gaia catalog for this field had like 2,000 stars in it. And so I was just switching catalogs to demonstrate that you could. This is something I do often as a troubleshooting thing. Like if the catalog has a bunch of stars that are like on top of a galaxy and that's messing with the background or something, I can switch to a different catalog to try to fix that.
Yeah, so we just recently implemented the Gaia catalog because I was finding that the APAS catalog had galaxy cores in it, and it was selecting those frequently, and that was leading to really large corrections to the instrumental magnitudes, the PSF instrumental magnitudes. So that was an attempt to avoid it, but yeah, there are a ton of stars, and that would be one of those places where either doing this interactively or when you check the photometry, if you use the no IREF option, you can see which stars were selected. And so when you're looking, at some point when you're evaluating your PSFs, you should look at which stars were selected and decide whether, you know, the diffraction spikes are in there and those are getting put into your PSF, or if galaxy cores are being selected, or things like that.
Thanks.
So how do you exclude galaxies here?
I do it mostly by changing the catalog. Different catalogs will have different objects in them.
I know, I remember DAO find it has showed the PSF shape, so you can choose yes and no individual object for this template.
So Asley, do you ever run this interactively? Is that?
So actually interactivity has broken with the switch to 64-bit IREF. And so if you're running 32-bit IREF, you can use the interactivity. We tried to get the 32-bit IREF running in Docker because you can do that, but there were file access issues that were a nightmare. And I thank Curtis for helping me hunt that down. So basically, we have said that there is not an interactive option for the PSF stage.
Unless you can convince NOAO to rewrite chunks of IRAF, which seems unlikely.
We went pretty deep into trying to solve this problem, contacting both Space Telescope and looking at NOAO help calls. And the other option is if you want to rewrite this in AstroPy, we accept any movements away from IRAF just because, you know, that is increasingly incompatible with current infrastructure.
I have a question about the star selection. When you does the pipeline do any cutoff like in Gaia to select only things that have a measured parallax to rule out galaxies, or using the classification from SDSS that is already built in to rule them out?
Yeah, so that's one of the reasons why we switched to the Gaia catalog, is because it does have those built-in parallax measurements, so we were able to exclude.
Because I ran into the same problem.
Sources.
I ran into the same problem, and the way I did it is just if the catalog has a measurement, any type of like size measurement, I can use a PSF minus Cron magnitude to pretty much rule out all of the galaxies to a pretty good level. And
yes, the Gaia catalog does that pretty well, and that's why we implemented that.
Okay.
And made it the default.
Right, you use elongation, right? X and Y elongation ratios.
Yeah, I mean, if you run, if you have the ability to run S-Extractor, one thing, I mean, this is, you know, I hate to make a suggestion that probably, you know, I should help actually implement, but, you know, so S-Extractor has a, you know, a stellarity parameter or whatever. It can tell, you know, if a thing looks like more like a galaxy or a star. And even if you don't want to run it on, like, to use it to find sources, you can still take your catalog and then run S-Extractor to get those parameters. And usually that does a reasonably good job of excluding things that are like binaries or galaxies or whatever.
Yeah, so these are all options we considered, and we welcome your contribution to the pipeline as a pull request. Or rewriting the stage. Everything is very modular in the pipeline, and so individual stages can be rewritten pretty easily. And one thing that we decided as a team was that it was a better investment of our time to try and create a new pipeline than to create like substantial improvements on this. So right now we update kind of bugs that are found or things that we really need to facilitate our reductions. But there's not major development happening on this pipeline. That was something we considered. We also, Curtis wrote the bonsai pipeline, which everything gets processed through. There's a catalog that's created as a result of that, that also has shape parameters that we could make cuts on. These catalogs are really just being used to select coordinates, which are being passed into the IRAF PSF task, and it's doing most of the selecting from there. And I'm happy to point people, I know that the code can be overwhelming, but I'm happy to point people to like relevant parts of the code if you want to see like how is this being done.
So is this code extension of IRAF instead of Python?
It wraps a lot of IRAF tasks in Python via PyRAF.
Okay.
And there was a reason we didn't use the S-Extractor star galaxy separation. It was not available in a certain version of it that we were using for, I don't know, some reason that Curtis said at the time, because I had suggested the same thing. That people were having, I can't remember the exact reason.
Yeah, so this code is grown very organically, I'll say. And so in certain places, we use the actual S-Extractor binaries that in the normal way, but then there are other places we use the Python version called SEP that Kyle Barbary wrote, and that doesn't include the star galaxy separation.
Is there something specific here to LCO images? Can I get a tar file of images from a completely different observatory, and would that break everything, or does it need some header keywords, or should I not have asked
I
that?
would guess that it would break everything.
Okay.
At least the ingestion. Maybe once you had all of the fields ingested, there's a utils file that has like a mapping of header keywords to, I think, something. I haven't dug that deeply into it, but I think that's probably where you would need to update this. I guess, Curtis, you've been actually adding a new camera, so you might be able to say more about this.
Yeah, I was going to say, it's certainly not impossible to add new cameras to it, but it's also not necessarily trivial. There are several places you have to add basically what the camera should do throughout the code. And so if you're willing to put the time into it, then nothing we're doing in terms of the analysis side should limit this to LCO data, but just the code needs to know what to deal with, or how to deal with things, basically.
Okay, and the other thing I wanted to ask while this is running anyway is that since this is all in Docker, I don't have to worry about upgrading macOS, breaking everything, right?
That should be correct.
Okay.
Modulo some statements about 64-bit, 32-bit IRAP, because on the current versions of macOS, it's 64-bit only. So if it's tricky to get 32-bit IRAF running on a new Mac. So if you need 32-bit IRAF, then you might want to stay in the old version.
So the Docker actually builds 64-bit IRAF. Because we're interacting with a 64-bit file system, there were issues with the file access numbers between IRAF and between building a 32-bit Docker image on a 64-bit machine. So I think the only upgrade issues would be like if Docker wasn't working, and that would be global, and we would try and fix that for everyone.
But there are instructions for using the non-Docker pipeline later down in the GitHub, right? So I think it is still possible to run this with 32-bit version, isn't it?
Yes, if you can build your own 32-bit IRAF, then yes. I mean, it was built for that.
You don't have to build it. It's just there, right? If you've installed it.
Yeah, no, I have zero plans of doing that. I was just wondering if for the now most recent macOS, which I've heard breaks some things, it shouldn't influence this.
As far as I know, that is correct. I'm running the newest operating system, and I haven't had problems yet.
Okay, nice.
Thanks.
And I'm assuming this is something that the new MacBooks with Apple Silicon are just going to break everything.
That is a good question. Supposedly, Docker is trying to make sure that they support the Apple Silicon. Whether that happens and how quickly that happens is a different question.
Okay. But you could still run it under emulation either way. It's just the question of will they run it natively, right?
Yeah.
Yeah, it looks like there's a preview version, at least, of the Docker running natively on Apple Silicon.
Nice.
but there are some questions on whether you'll be able to deploy those on different machines and some of the deeper technical questions that people are still trying to solve.
Okay, again, I apologize. This step is taking so long. It's usually much shorter. I have no idea why the APAS catalog, which was my like smart fix yesterday, is not working. Let me try to do.
I mean, Jamie, do we have enough calibrated that we can keep going? Does it matter that we have all, was it like 12 observations with PSFs?
Okay, we've got 4 more. It would be nice to have the full set. Whoops, that's actually not. Okay, so to explain what I did there, I'm just going to rerun the command without use extractor because I think that actually wasn't any faster, and I'm running it without the -f at the end. So this will only do it for images that don't have PSFs. So I'll just copy that command. So yeah, for a lot of these, it'll say PSF already calculated. I'm going to skip it. Interesting. Okay, I realize we will need a populated APAS catalog for a later step, so I'm going to go get that. Okay, sweet.
So Jamie, should we download this file and put it somewhere specific?
Yes, so it's just about to write those.
Sorry.
Oops, I didn't write that correctly.
So there was a file there, but it was much smaller. That might be the reason we were getting the errors before.
Yeah, so I'm not sure what happened because it wasn't. If you look at this file, there's a header with what the columns are, and then there are a bunch of columns, array deck, and then magnitudes and different filters. And so, yeah, for some reason it was not crashing, but and it seemed to be contacting the APS server okay, but it was just outputting the header and not any of the actual information. So it was empty, and since it didn't know where any stars were, it couldn't use it. So again, no idea why that happened, but here we are. Okay, we should be done finally. Everything's going according to plan. Okay, so I just did the previous command, but without any stage information. So just to look at the data, they do all have PSFs listed here. So that's great. If we want to look at them, I'm going to copy the next command that's in the file. So this stage is check PSF, and then I'm also passing it this no IREF flag. Okay, so here is the image, and this is a Python plot, so you can just zoom in and out. Again, it's all the stars that it had access to in the whole catalog are in red, and now the stars that it's picked for the PSF are in blue. So you can see it picked out 12 stars. This is what the PSF looks like, and the no IRF stage is better because this is manipulatable. You can spin this around and see if on any side if there's anything weird going on. This looks totally fine, so we can go through. I actually don't know what these will look like since most of them, since they were made with Sextractor, but they all look pretty typical to me. The three options here are if you don't press anything, it's a good PSF. If you say N, it's a bad PSF, so it'll let you can redo that image. Or if you press B, this is marking the whole image as bad. So like maybe some disaster happened and like the shutter got stuck and like the whole image is messed up. So like if you want to throw out the entire image, then you would say B for bad quality image. But that's quite rare these days. Okay, so looking through, these PSFs look pretty typical to me.
So what are red circles and blue?
So the red stars are the entire set of stars that it could have picked from in the image. And then the blue stars are just the ones that it used to build the PSF. Okay, cool. All those PSFs looked fine to me, so we'll go on to the next stage. That's the PSF mag stage. So now that the image has a PSF, we're gonna measure the PSF and aperture magnitudes of the supernova. This stage is usually significantly faster, so that's good. It does print a lot of stuff out to the screen, but I usually don't pay attention to it much unless there's some big error message somewhere.
So one thing to look at here is if sometimes there's something funny and all of the aperture magnitudes are not magnitudes, they're like 999, like they're all failing. But if you, that's usually a sign you need to set data min or data max, and that fixes it. That's the only thing I really look at this stage.
Set them in the PSF stage?
No, when you run PSF mag,
okay.
you can pass data min and data max in.
So what does that mean?
It's good values that are passed to IRAF. That's the extent of my understanding. I think it populates data min and data max in IRAF.
But what we're doing here is measuring the magnitude of just our supernova, right? Using the PSF we've already created.
It does both PSF and aperture photometry at the same time.
Right, but what did data min and data max mean? Does it filter out something or?
I assumed that it was like a masking pixels or something, but I don't know.
Okay.
This is empirical.
A phenomenological observation of the pipeline.
Got it.
Okay. Good. Okay, so the next thing I'm running here is the next step in the tutorial. So I'll post that here just for completeness. This is the check mag stage. So there's the check PSF stage, which lets you look at the PSFs, and the check mag stage that lets you see how the PSF extraction went. So this left here, this is the image Schuber's zoomed in on the supernova, on the object. And then the right is what the residuals look like after you subtract off the PSF. So ideally, the right image should just be like, you know, flat noise. It doesn't always look like that, but that's fine. A lot of the time that I spend doing reductions is spent in check PSF and check mag stage, just looking at these and kind of subjectively, to be honest, deciding which ones are bad. So like these are not great residuals. You want them to be flat, and there's clearly like a snake bite left there. So again, you can mark things as bad, mark the magnitude as bad with N, and then that lets you go back and redo the stages that you want.
Jamie, can I ask a question? So I usually run the get mag stage and look at the actual light curve, and then I click on the points to pull up this plot if something looks funny, rather than inspecting every one. On one hand, that allows you to only look at the things that don't fall on the light curve. On the other hand, there's a confirmation bias in that you're only looking at the funny ones and you're not kind of excluding blindly ones that are redoing ones that look funky. I guess I was just wondering what your thoughts were on that.
Yeah, I try to go through this stage for all the data, just to make sure, like you said, that I'm not introducing any confirmation bias in there. Also, it's pretty quick, even if you have a large data set, especially if things are going well, like you're just kind of clicking through and like making sure nothing looks obviously weird. So it's not a super long process, but I do try to do this stage for all of the data.
Cool, thanks.
So what about showing the light curve, you know, using the initial value, you show the light curve, then you go through this step, and, you know, so we already know weird data point we need to give more attention, because, you know, scale can be misleading here if you don't know absolute numbers.
That's true. So I usually do that as the last step. So we'll see what that step looks like more when we have the full light curve. You can look at a magnitude of just you can look at a light curve of just the PSF magnitudes, but I usually look at that in magnitude space.
Right, but it's separate. You see light curve or either this step, but if we can look at together, I mean, we'll give more attention that weird data point perhaps.
That's true, and yeah, the last thing I'll do is looking at both of them at the same time. So let's get to that, and then that might make more sense. Okay, so like I said, there are 4 main steps: the PSF magnitudes, 0 points, and then actual magnitudes. So the next thing we'll do are measuring the 0 points. So for this, I'm going to look you have to do it in 2 steps. One set of 0 points for the Landau images, UBV, and then one set for the Sloan images, GRI. So I'll do Landau first, and the stage is called ZCAT, and hopefully this will work where it can see the APAS catalog. Okay, sweet. Let's go. And I will post these in the chat. Oops.
Yeah, so this was something that I didn't realize at first, which is that there's a color correction in the 0 point stage and the apparent magnitude stage. And so if you only give it a single filter, it will still calculate things, but I don't know if it uses a canned color term or if it just doesn't use a color term. So you always want to use at least 2 filters. And the easiest thing is just to, like Jamie showed, use the Sloan and the Landau filters.
That's correct. Yeah, that's a good point to make. I always try to do stuff in filter batches so you have the color terms. Okay, so as Lee just said, I did it for Landau, and then I'm going to do it again separately for the Sloan filters. So that ran pretty quickly. Good. So then lastly, we're going to do the mag stage. So that just uses the PSF magnitudes and the 0 points. So cool. We have successful magnitudes and error bars. If we want to look at those, we can do the get mag stage. You can specify what, this will pull up a light curve. So actually, let me just do that. Okay.
Jamie,
cool.
could you say something about the type keyword?
Yes, that's what I was about to do. So right now I'm looking at this light curve in magnitude space. So these are, like physical magnitudes. You can pull up this light curve in PSF magnitude space or aperture magnitude space if you want to look at it.
Jamie,
like
can I clarify? So this is mag is apparent magnitude.
Oh, yeah.
And so the 0 points have all been applied and all the different telescopes effects should all be canceled out. You can look at instrumental magnitudes and there you get to choose between aperture magnitudes and PSF magnitudes. So aperture is pH and PSF is fit. And that's if you want to look at the instrumental magnitudes, and that's the default is fit. So if you don't specify type here, you will not get apparent magnitudes. There's a single mag column in the database, and so whatever you use to at the mag stage, that's what will be populated. So if at the mag stage you specified type equals pH, then you have aperture apparent magnitudes. If you specified type equals fit or you didn't specify, then in your mag column, your apparent magnitudes will be from the PSF instrumental magnitudes. And there's no way to tell what you did, so write it down.
Yes, perfect. Thank you for the explanation. That's great. So this was, I think, what Chunky you were asking for. So this is looking at the light curve, and then if you click on that point, then that'll bring up what the image looks like, what the image centered on the supernova looks like.
Okay, good.
So typically so SNUX automatically reduces all of the data. So a lot of the time, a first pass through the data is just looking at an automatically reduced light curve and then going oh, this epoch is clearly out of place. Let me let me run this stage and like click on those points and see what went wrong there.
So Jim, if you move your light curve down a little bit, you'll see that here you actually have the option again to delete. That's kind of like no in the previous stage. So that I think removes everything up to the magnitude, like all of the instrumental magnitudes, and allows you to redo it. Marking it as bad eliminates you basically from ever seeing this file again. That's only extreme cases. It's a little harder to bring that back. U doesn't currently work. It, I think, deletes the file if you try and press U. So the upper limit doesn't work. And that's marked, that's noted in the manual. And if anyone has used the Matplotlib GUI and wants to fix why that doesn't work, that would be welcomed, but it hasn't risen as a high enough priority. There's a column in the database that specifies whether something is an upper limit or a measurement, and that just updates that column.
Yeah, so to demonstrate one of those options, which is the one that we use most frequently, that's that D option. So I'm going to press D. That has deleted that point. So if I go and look at my data, one of them has a bad magnitude. You see the rest of them have filled in magnitudes except for the one that I deleted. And then if I want to pick out just those points that I deleted, you can put -B, which stands for bad magnitude. And so that includes the U-band data, which hasn't been calibrated yet. That's the next thing we'll do. And then that one that I just deleted. So you can go through the light curve, you can delete points that you want to redo, select those with -B mag, and then rerun the PSF or the PSF mag stage or whatever. Okay, sweet. So now we're going to do, so that was the first thing. That's like the basic reduction, those 4 steps that I mentioned. Now we're going to do the U-band reduction. So I'm looking at my data. I'm looking at just the Landolt filters of my data, and then I'm getting all the standards that are associated with that. So one of the tar files has these standard observations. I bundled
Jamie,
those for you. Yeah.
Can I take a step back? So for all of the other filters, we had the APAS and the Sloan catalogs. So we had apparent magnitudes for all of the stars in the field that we could use to calculate the 0 point. For U-band, we don't have that. And so what we have to do is create that catalog for our supernova field. And we do that by using standard star observations taken on the same night as our supernova. So that's what we're going to be doing now, is creating those supernova field catalogs for U-band.
Yes, yeah, thank you. That was good context. Yeah, this was the APAS catalog file that I posted, and you can see it has BVGRI measurements, but no U-band. There's no U-band all sky catalog. If there were, that'd be sick, and we wouldn't have to do this, but there's not, so we have to make our own. So just copying the next command in. This is using those associated standard fields and then running this local stage. That's definitely not what's supposed to happen. Oh, I know what happened. I didn't read my own tutorial. Nice. Okay, cool. So these local fields also need PSFs to work. So I am not used to doing this step because on the Supernova machine, all these data get ingested automatically. But locally, you do have to run your own PSFs. So we'll just generate PSFs for the standard stars, standard field.
So there's a set of 8 different Landelt standards that we have Landelt catalogs for, and we'll send around a tar file so that you can put all of those where you put this L101 file, and then that gives you access to any standards that were taken on that night, because we don't always take only L101 as the standard.
But I'll need a standard field taken on one of the nights that the supernova was already also taken, right?
Yes.
So how do I get that?
So
I get it from it goes through the fields in SNEX and
no, you have to find it in SNEX and download the appropriate standard.
I see. So I have to go through the fields in SNEX and see which one was observed on the same night as my supernova.
So what I've done, if you have the space, is I just download all of the standards. This is what LCO does, I believe, is just download all of the standards for the period of time that you want to calibrate. And the LCO or LSC loop will do the matching and identify the appropriate standards.
Okay, that makes sense.
So just one quick note on that is that's the query that we were running to do that used to take a very long time if you ran it incorrectly. And so we've been actively working on that part of the query. I think we have a solution to that, but it's not merged yet.
And that's not an issue for every supernova, but I'm not sure we've totally identified when it's not.
Well, on a local database, it might be faster, but because it doesn't have all the data.
Yeah, the cross matching could be faster.
Yeah, like for me, it finds it like basically automatically, like it automatically pulls up the associated standards. But I also only have like 20 things in my database instead of 200,000 or whatever's in the Supernova.
So Azali, what you said you would post is the list of standard fields that one should download.
I'll actually send around the catalogs. Like Jamie sent around the L101 Landelt catalog. This is just the rest of the standard catalogs so that you can build the 0 points of the standards.
Got it.
And Curtis and I are already talking about throwing this into Docker eventually so that, because it's an important part of running the pipeline.
Yeah, there's an infinite number of improvements we can make. So if anybody feels like it, feel free.
Okay, so
this is already amazing, the fact that this all runs with very little effort.
Okay, so I ran 2 things. I ran the PSF stage and the ZCAT stage on my standards. Now I'm going to run that local stage, so hopefully this should work this time. It skipped eBay. The
Did you need to run the mag stage as well?
I don't usually run these stages, so I don't.
But your manual says to run the mag stage.
Ah, how helpful. Thank you.
PSF mag or mag?
I think PSF mag, according to the manual that I wrote yesterday.
No, it says to run, yeah, PSF mag, sorry. And then Zcount.
I know. I think I might know what's going on. Okay, so what had happened was that it wasn't saving PSFs. Normally this column is where the PSFs are listed, but those were bad just for the U-band images. I think those are working. Okay, so I will post this command in the chat.
Yeah. So there's a misleadingly named value called a parameter called aperture correction, which is an attempt to correct for the differences between the PSF and the aperture photometry. But it's, why I say misleading is it's correcting the PSF to the aperture photometry. And it's not because you have a smaller aperture, which is what I think of when I think of aperture correction. It's due to like imperfections in the PSF fit. So if this correction is large, the assumption is that there is your PSF model is maybe not doing a great job at actually modeling your PSF. And so we set a fairly conservative cut where if your aperture correction is too big, I think if it's bigger than 0.1 mag, then the PSF stage fails and a PSF file isn't created. But if you still want to create the file or you want to investigate why, you can always set that max apercore keyword to be something bigger than 0.01 and then actually process those files. And Jamie, if you scroll up, let's see, a little bit higher, there, stop. So here it actually tells you what the aperture correction is. And so that's how you can troubleshoot if that's the reason. It'll say that, and then if it's too big, if it's bigger than whatever max apercore is set to, it'll print to the screen that the aperture correction is too big, and it'll print what the max apercore is set to. And then this update here, instead of updating PSF with the PSF file name, it'll update it with an X and do all of the subsequent steps from there.
So basically that aperture correction is different from PSF photometry. Is that the number?
Yeah, it's the difference between the aperture and the PSF instrumental magnitudes. For all of the catalog stars in the field. So it's not just looking at your supernovae, it's actually doing an average of the catalog stars in the field, or median.
Yeah, this value was the subject of much investigation, especially over the summer and the fall. Asley Asley has explained it to me and the rest of us several times, and it's still slightly mysterious to me. I think she's the only one who understands it on a deep level.
So we ultimately traced most of the failures down to the cores of galaxies being the first PSF star selected and setting the normalization of the PSF. And that was what motivated both flagging this, but also moving to the Gaia catalog rather than using the APAS catalog.
Okay, so just gonna paste the last few things that I did. Okay, so at a long last, sorry, I forgot to write these in the instructions, but we are on to the local stage. So this is the stage that, as I mentioned at the start, we're going to make our own catalog. So I'm actually going to go to BBand because this makes the most sense. Okay, so these plots have a lot of information. When Griffin first explained them to me, he was extremely excited about how much information they contained. What they are is the top panel over here. The x-axis is looking at by star, and the y-axis is the apparent magnitude. The orange circles are each star's magnitude in the APAS catalog. The blue circles are the new measured magnitudes for that star with the new 0 point that we've calculated for the telescopes. That's what this plot is. On the right, that it's basically that same information, except looking, instead of by star ID, it's looking by apparent magnitude, and this y-axis is now the offset between those two values. And it also marks the median offset here, which you can see is like a centimag, so for our precision, pretty low. And then this bottom plot makes more sense if you have a lot of standard observations. Right now we only have 2 images, but normally there would be like 50 or 100 on here. But this is, for each image, it lists the same information, like the offsets for each individual star, which is what the dashed line is, and then what the offset is from the catalog, and then the median offset over here.
It also shows you how many standard stars matched your field on over the whole course of the data that you're looking at. And so that gives you an idea of, like, if you only have 1, then you only have 1, but if you have like 10, then you're averaging all of those to get like a better catalog. This stage is where I caught a bug where the second time, if you ran this twice, it chose all standards, regardless of night. That's been fixed. But that's what this can be useful for, is just seeing, well, how many nights do I have standards that match?
And also, if there's a like large offset in between your APAS catalog and your newly generated catalogs, then that could also be an indication that something is wrong. Maybe the PSFs you generated for your standard fields are wrong and you should redo them. That's another thing to check as well. Okay, so it does this for each filter. So that's the B band image, and let's look at the V band. So the offset here is slightly larger, but still a couple centimegs, so pretty normal for our precision and for APAS. That's cool. And so now it has written a new catalog of stars in the field in the field of 17 CBV with U-band magnitudes. So we're going to use this catalog. So this command, I'm rerunning the zcat stage on our Landau images, and I'm specifying, instead of using the APAS catalog or whatever, we're going to use this new catalog that I just generated. And I'm going to force that so it redoes it for the B and the V. Okay, before the first thing it printed out was like, can't calibrate U-band or something like that. Now it's doing the U-band, so that's good. And then if we rerun the magnitude stage, then now those U-band images have correct magnitudes. So now if I run the getMag stage, then I have the full light curve, including U-band at this point. Okay. Cool. So that's that. So there are some extra steps to do U-band, especially ingesting the correct standard fields. Again, you have to find things on the same night and on the same telescope as your science observations. That can take some effort together, and then to make sure that they have good PSFs and all that. And then you generate your new catalog, and then you're good.
So Jamie, is the next stage difference imaging?
So I was going to do one more thing before difference imaging.
We're approaching a 2-hour mark.
We are indeed.
And I'm wondering what people's availability is and if it makes sense to try and do this like same time next week or something to keep going. How are people feeling? You can either unmute yourself, or if you want to give us just some reactions, that's fine too.
How much material do you have more to show?
I would say with difference imaging, we're halfway.
Only halfway?
I don't know, Jamie, what's your opinion? Maybe it would go faster.
Yeah, I was going to guess another hour.
So probably next week, same time, at least for me, because it's getting a bit late here.
Yeah, I have another meeting I have to run to too. Maybe in the meantime, we can have our troubleshooting and try and get everyone with a running pipeline by next Tuesday.
That sounds like a good plan. So should I send out another doodle, or do we just want to say this time next week?
I'm inclined to say this time next week. I guess, do people see their little reaction happy face? Can you give us a no if you can't do next week? And maybe a yes or a thumbs up if you can do this time next week.
Okay, seeing a lot of thumbs up and yeses.
apparently the new version of Zoom makes yes and no back to being persistent, which is useful. Okay, I haven't seen any no's, so I'm gonna say same time next week.
Okay, sweet. Then I will